Hello, geometers and seekers of general truths. In this video, we are going to perform some dilations here with pictures on an XY coordinate plane. And when we use the origin here as the center, the dilation is relatively simple. So let me illustrate how this is done. So first, this is my center here, that's the origin. And I'm going to start out by measuring the length from a point to the origin. So we're going to dilate point M, center at this red dot right here. Now the length from M to that red dot is simply to calculate. It's 3. 1, 2, 3. Okay. Our scale factor here is 2. All right. So all that means is that from the center to M prime must be a distance of 6. So I simply go up 1, 2, 3, 4, 5, 6. Okay, so from C, from the center to M prime must be twice that size. Okay. Similarly, for my point L right here, this length here is 4, right? So when I go to dilate it, I have to move twice that distance because my scale here is 2. So 4, 5, 6, 7, 8 is going to be out here. And so this is where L prime will be located. Just to be clear, this length here is going to be 8. Right? Now, the point N gets a little bit more tricky because it's not on one of the axes. It's out here. So we can simply, when we're using a coordinate plane, and I will prove this in a later video, we can look at the horizontal distance. So from the origin. So from the origin, I'm going 2 over and 4 up. Okay? 2 over and 4 up. And if I'm dilating by a factor of 2, then my new point will simply be twice these original distances. So instead of going 2 over, I'm going to go 4 over. And instead of going 4 up, I'm going to go 8 up. So I'm going to go up to here. So up here is where N prime will be located. All right. So the short of this is that instead of trying to draw a line directly from N to the origin, duplicate the length of that line segment to find N prime, we can just use the coordinates. If each of the coordinates are increased by 2, then the total distance will also increase by 2 because we have some similar triangles there. So let's make this connection from M prime to L prime to N prime back to M prime again. So this is going to be my triangle. All right. And just to show you these coordinates here are 0, 6, 8, 0, and up here that's going to be 4, positive 8. Okay. And maybe we can look at this and deduce some sort of pattern. So we can look at the image matrix, right? So the image matrix is really nice because we can look at this and we can deduce a pattern from the image matrix, and we can apply it to other situations as well. So the coordinates, oops, I don't have A, B, C. I have L, M, and N. Okay, so let's try this again. Whoops. I have L, M, and N. The coordinates of L originally was 4, 0, M was 0, 3, and N was 2, 4. After I perform the transformation, L prime, M prime, and N prime, I get L is 8, 0, M prime is 0, 6, and N prime is 4, 8. Okay, so this was a dilation with a factor of k equals 2. So you can see here the pattern is pretty simple to deduce. All we do is take all of these coordinates here and double it. So 2 times 4, 2 times 0, 2 times 2. That gives us the first row. 2 times 0, 2 times 3. 6, 2 times 4 is 8. That gives us this row. Okay. And with that in mind, we can solve the next problem here without necessarily having to do too much work. We can set this up as follow, GHI, okay? And this time we're doing this with a scale of 1/3. And we can certainly do the same process of graphing it here like we did in number 1, but with this pattern that we've deduced, we can speed up the process a little bit. So the coordinates of G, and you got to be careful with your scale here, 2, 4, 5, 2, 4, 6, 7. So it's 5, 7. Coordinates of H, 2, 4, 6, 8, 9, and Y coordinate is 3. I is 3, 1. And if we're multiplying or we're transforming this with a dilation where K is equal to 1/3, well, the numbers follow a really nice pattern. All we do is multiply every single one of these coordinates by 1/3. So I'm going to get 5/3, or 1.6, 3, and 1. Okay, so 5 times 1/3, 9 times 1/3, 3 times 1/3. And the bottom, I'm going to get 7/3, 1, and 1/3. 7 times 1/3, 3 times 1/3, and 1 times 1/3. And that's going to be the coordinates of G prime, H prime, and I prime. So, to hammer home this point, when we are using the origin as the center and we have a dilation, it's pretty simple. All we got to do is multiply all coordinates by the scale. Okay, all we got to do is multiply the coordinate by the scale, as long as the origin is at the center. We'll look at a problem later on in a different video where the center is not the origin, it's some other point. But for now, that's a great starting point. Some good practice here. Keep working hard. Ask for help when you need clarification. Thank you for watching and have a wonderful day.